Okay, hello and welcome to our algebra lesson for today. Today's lesson is lesson 3-3. Yesterday you went ahead and looked at solving inequalities when you are adding and subtracting. Today we're going to take a look at solving inequalities using multiplication and division. So let's go ahead and start off with our anticipatory set. Our anticipatory set today is really just going to be a very basic version of what we're doing today. Okay? So all of us can agree that 4 is greater than 1. We can all agree that. I don't think there's anyone out there going, wait a minute, that doesn't make any sense. So I think we can understand this concept. Now, what we're going to do is we're just going to go ahead and use this basic concept, and I'm going to go through some things that you probably learned maybe in 3rd, 4th grade. This is also going to have a little patterns icon with it, because you'll see a pattern here. Okay, so let's start, and we're going to multiply each of these, and we're going to see what it looks like, okay? So if we say, let's say 4 times 3, and on this side we're going to have 1 times 3, I think, again, all of us can understand which way it's going to be. So right now, we've taken the two numbers that we had here, and we multiplied them by the same number. But we realize 4 times 3 is going to give us 12, and 1 times 3 is going to give us 3. So obviously, that side's still going to be bigger, right? Let's go ahead and try one. 4 times 2 and 1 times 2. Again, 8 is going to be more than 2. Let's check with another one. 4 times 1, 1 times 1. Again, 4 is going to be greater than 1. Now, let's take a look at what we can see here. 4 times negative 1. 1 times negative 1. Now, looking at this, look what happens here. 4 times negative 1 is going to give us negative 4. 1 times negative 1 is going to give us negative 1. Which one's bigger? Oh, our sign is going to flip. Let's make sure that wasn't a fluke. 4 times negative 2, 1 times negative 2. 4 times negative 2 is going to give us negative 8. This is going to give us negative 2. Again, this side is bigger. And finally, let's close it out with 4 times negative 3, 1 times negative 3. And you can see that 4 times negative 3 is going to be negative 12 as compared to negative 3. Negative 3 is going to be more than negative 12. So you can see that pattern there, and you can see that at a certain point, our sign flips. And that's going to be really important to what we do today. So if you look at this right now, when does the sign flip? Well, as soon as the multiplication becomes negative. Okay. We have a few standards to write down. So let's go ahead and get started with our standard. Our first one is going to be A-CED.1. And we've done this one before. We're gonna write it down. We're gonna actually we're gonna write just sort of the main ideas of this one. Okay, we're gonna make it a little bit smaller. It's gonna say create, and then go ahead and put an ellipsis right there. Create inequalities in one variable and use them to solve problems. So that's not the full standard, but that's the part of the standard that we're focusing on today. Create inequalities in one variable and use them to solve problems. We are also going to have A-CED.3, which is another one we have done before, but we're expanding on these standards. And this one says solve linear equations and inequalities in one variable. including equations with coefficients represented by letters. All right. So we have two, and we actually have one more. And that's going to be N-Q.2. And what this one says is that we are going to define appropriate quantities for the purpose of descriptive modeling. All right, those are our standards for today. We have three of them. The main ones are obviously going to be these two right here. We're going to be creating inequalities in one variable and using them to solve problems. We're also going to be solving linear equations and inequalities, for the most part today, inequalities, in one variable, including equations with coefficients represented by letters. All right, and then down here, define appropriate quantities for the purpose of descriptive modeling. And that's really just the way we present the information. Okay, so let's go ahead and get started with our actual lesson here. We're going to get into some input. We have no language of the discipline. We've learned everything we need to know for this. We just need to look at some examples here. So let's go ahead and get into the first thing we're going to be talking about today. Ooh, that was a good flower. All right. Day's getting off to a good start. What we're going to be saying here is we're going to be learning about the multiplication property of inequality. The multiplication property of inequality. So we have a property we're going to be talking about here. And really, this is going to be some important details for you to write down. This is going to be explaining what we're talking about today. So I'm going to go ahead and try and color code these pretty well, okay? So I'm going to be putting my titles here in pink like that so you can see it. And then I'm going to go down and I'm going to be using two different colors. I guess I'll use purple and green. Purple for sort of the main idea, and then green as sort of the details about it, okay? So underneath here, I'm going to go ahead and put a little star. And then the important thing that we're going to be talking about is the rules that these numbers or these variables will have to follow. So we are going to let A, B, and C be real numbers with C greater than 0. So the situation I'm describing right here, A, B, and C are all real numbers, and then C is greater than 0. So any number greater than 0. Now, if that's true, then we have two different things we can see. If A is greater than B, then A times C is greater than A. Oh, I totally messed that up. B times C. That's the first part. So if A, B, and C are all real numbers and this C is greater than 0, then if A is greater than B, A times C is greater than B times C. This also means that if A is less than B, then A times C will be less than B times C. And that seems pretty simple from just looking at it right here, right? But let's go ahead and look at the next part now. So I'm going to go back to my purple now because I'm going to my next sort of bit of notes I want to write down. And it's going to be let A, B, and C be real numbers with, and now look at what we're going to be changing here. C is less than 0. Okay, so when we're multiplying, if they're all real numbers and C is greater than 0, these two things will happen. If they're all real numbers and C is less than 0, meaning negative, then we have two things again. If A is greater than B, then A times C, and now here's where it's different, is less than B times C. And if A is less than B, then A times C is greater than B times C. Now again, that's kind of confusing to hear it just said out loud. That's why we really want to write it down and use these color coding to really make our notes look good. Okay? Now, we know from up here in our anticipatory set, this is stuff we've known for years and years and years, right? That 4 times 3 is greater than 1 times 3. 4 is greater than 1. We know those facts. As we get here, when we multiply by a negative, you can see that 4 times -1 will be less than 1 times -1. So that's really what this is saying. We're just moving the difficulty up a little bit. So we have 3 numbers. We're going to see an example of this right now before we move on. But make sure this is written down somewhere where you can go back and reference it. It's very important that you can do that. So we're going to keep that handy. I'm going to go ahead and take a new piece of paper. And what we're going to do is we're going to do a little bit of input along with modeling. I'm going to draw my flower. Very nice. All right. We're going to take a look at a little bit of modeling. So what we're going to be doing first is we're going to be multiplying by a positive number. So we just saw what will happen when you multiply by a positive number. That's going to be this top part. So we're doing this top part first. So you'll be able to see the two rules right here. If A is greater than B, then when we do the multiplication, A times C is going to be greater than B times C. Same thing down here, we're going to follow this rule. So we're doing this top part right now. Okay, so let's go ahead and get into our example. And I'm just going to say x over 3 is less than -2. Now you can see we're going to take this and we're going to apply it to an inequality that we have. So we have an inequality right here. Whatever number fills in for x, it must make this expression true. X over 3 needs to be less than -2. Now how do we find what the solutions are? Now, you could just guess every number in existence and do the equation each time and check off the ones that are correct, but that would take a lot of time and you'd never be done. So let's go ahead and take a look what we're going to do. It's the same thing as if this was an inequality. We just need to be a little bit more careful. So first things first, I'm just going to go ahead and rewrite it as I always like to do. X over 3 is less than -2. Now, the rules we have when we were trying to solve an equality is to get x alone. And yesterday, when you did your lesson on this with addition and subtraction, you did this already. You know you're going to be adding and subtracting to get the variable by itself. So let's go ahead and do that. If I have x over 3, that means I need to get x alone. How will I get rid of this? Well, I'm going to multiply this by something, and I need those 3's to cancel out. So I can multiply this by 3, because 3 can also be written as 3 over 1. The 3's will cancel out, leaving me with x over 1, or just x. Now, on the other side, obviously, I need to be doing the same thing. So negative 2 is going to be multiplied by 3. I don't need to write it as a fraction because negative 2 is not a fraction. Okay, now I can write out, and again, just on the side here, I'll write out multiply each side by 3. There we go. So we've done that. Now we get into our next step, which is always just to simplify. So let's simplify this. On one side, we're going to have x over 1, which is just going to give us x. Now, this is the important part. We multiplied a positive 3 to each side. Now, let's go back for a second. What does the rule say? That third number we're multiplying, is it positive? It is greater than 0. 3 that we multiplied to both sides is greater than 0, meaning if A is greater than B, then it's going to stay the same. If A is less than B, it's going to stay the same. So let's look at the sign. It says less than. It's going to stay less than. Negative 2 times 3 is going to give us negative 6, and that's going to be our answer. Now, finally, if you wanted to graph this, as it's always good to graph these, we can go ahead and just draw out our number line. And we'll say negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Okay, so you just have your little number line right there, and we're saying that all the values that are solutions are going to be less than negative 6. So we know that it's not going to be negative 6. So we're going to have an open circle, and then we're going to be less than negative 6. So there we go. We just graphed our solution right there. So that should be pretty easy. Multiplying by a positive number is very easy. We've done things like that before. Now let's get into our next bit of input and modeling. There we go. And we're going to be multiplying by a negative number. Okay, again, we're going to be using the rule we just saw when we wrote it down for our property. This one's going to be a little different. So again, I'll write out our question. It says, what are the solutions of negative 3 over 4 W is greater than or equal to 3. Graph the solutions. Okay, so there's our question. We see it right there. So obviously my first step is going to be rewriting the problem, which is going to be negative 3 over 4 is 3 over 4 W is greater than or equal to 3. Okay, now what am I going to do next? I just need to get my variable alone, which makes this kind of easy. All I need to do is get rid of that negative 3 over 4. So I'm going to go ahead and multiply by the reciprocal, because if you multiply by the reciprocal, it cancels out. So if I do that to one side, I'm going to multiply this entire side by negative 4 over 3. We know that a negative times a negative will be a positive. The 4's will cancel out. The 3's will cancel out, and we'll be left with W. This side, we're going to do the same thing and multiply by negative 4 over 3. Now, very important thing to remember. When you multiply by a negative, the inequality sign flips. And we know that because if we look back at our property, now we're talking about a number negative 3 over 4, sorry, negative 4 over 3, which is what we're multiplying by, is C in this situation. And it's less than 0, meaning if A is greater than B, then A times C is going to be less than B times C. So since we're dealing with a negative number, that sign is going to flip. So we're going to rewrite now and simplify. Since all of these canceled out, we're going to have W. It was greater than or equal to. Now it's going to be less than or equal to 3 times negative 4 over 3. Obviously, we can write 3 as 3 over 1. These 3's will cancel out as 1. And it will be negative 4 over 1, or simply negative 4. So we've simplified. We've flipped our sign because we multiplied by a negative. So W is less than or equal to negative 4. We can again write out our number line because we need to graph the solution. We'll start with negative 2, negative 3, negative 4, negative 5, blah, 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 blah. This time, we are including negative 4. So it needs to be a solid dot and anything else that is less than negative 4. Okay, so we've done our multiplication now. Let's go ahead and get into the next part. Now, this is just going to be some details again. Oh, I'm getting good at drawing flowers. Okay, and this next one is going to be called the division property of inequality. Now, just like the multiplication property of inequality, the division property of inequality looks the same. Again, I'm going to take the two colors I was using, purple for the main idea, and then my green for my details there. The main idea is you're going to let A, B, and C be real numbers with C being greater than 0. It's exactly the main idea that, or the idea that we wrote down in our multiplication property. So we can see that the same rules, similar rules are going to apply. So let's go ahead and write that down. If A is greater than B, then A divided by C is going to be greater than B divided by C. So again, if you look at that, A is greater than B, then A divided by C will be greater than B divided by C. Same thing we're saying, if it's a positive number, the sign will stay the same. Let's take a look. If A is less than B, then A over C is going to be less than B over C. Excellent. Okay. Let's continue on. If we have C being less than 0, let A, B, and C be real numbers with C being less than 0. In the same way as before, there's going to be some rules that apply. If A is greater than B, then A divided by C is going to be, and we're going to flip the sign, and it's going to be less than B divided by C. And then if A is less than B, then A divided by C, we're going to flip the sign, is greater than B divided by C. So there we go. That again is our rule. And again, we're going to go ahead and have 2 examples. I'm going to go ahead, I have some room, but I'm going to go ahead and move to a different page. Keep that handy though, because that will tell us what we're doing. Okay, and let's get into a little bit more of our input modeling hybrid here. The first one is going to be dividing by a positive number. Okay, so dividing by a positive number first. Here is our question. You walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? So that's our question. Walking dogs in your neighborhood, and you earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? So we need to first think about this. This is going to be a word problem here. So there's a few things we need to do. How do we figure this out? We first need to figure out the cost per dog. You're getting that much per dog. So we're going to have the cost per dog. Then we're going to be multiplying that, because each dog you get, you're going to get $4.50 more. So this is going to be a multiplication problem. Next, we have to figure out, what do we need to multiply the cost per dog by in order to get our answer? Our answer is at least $75. Well, we need to multiply the cost per dog by the number of dogs you're walking. Now, we won't say equals because it says at least. So we'll write instead is at least. And then our answer, which is going to be $75, or the amount wanted. So that's a word way of writing out our problem. Now let's go ahead and write that out as an equation. I'm sorry, an inequality equation. Okay, $4.50 is going to be the cost per dog, right there, times the number of dogs. What is the number of dogs? We don't know yet. That's going to be our variable. So we need to make a variable for this. I'll just make it easy and say this is going to be D. 450 times D is at least. So that means is equal to or greater than. So greater than or equal to the amount wanted, which is $75. So there is our equation. Now I'm going to go ahead and write it out again. 450D, take that multiplication sign out, is greater than or equal to 75. Now we need to divide. We need to get that variable alone. So we're going to go over here and divide by 450. Obviously, 450s will cross out and we'll be left just with D. But we also need to divide 75 by 450. Off the top of my head, I don't know what 75 divided by 450 is. It's a few ways you can do that. You can estimate it. You know what 5 would be, and you'd have to work back that way. I'm just going to go over on the side because you should never be afraid to use scratch paper when you're doing notes. And I'm just going to go ahead and guess. First of all, I'm going to say 450 goes into 75. How many times? And what we need to remember is moving that over. Decimals right here, move that over 2 as well. Fill those in with zeros. There we go. So now we're doing 450 into 7,500. First thing we're going to do, 450 can't go into 7. 450 can't go into 75. 450 can go into 750. How many times evenly? Well, 2 times would be 900. So that doesn't work. So it would have to be 1 time. 1 times 450 is going to be 450. We subtract 0 minus 0 is 0. 5 minus 5 is 0. 7 minus 4 is 3. 450 cannot go into 300, so we need to drop the 0. How many times can 450 go into 3,000? Again, off the top of my head, I don't know, so we're going to do a little bit more work. Remember, don't be afraid to do scratch work. You should always be able to do that on the side. So let's start by saying, 450. What would I multiply 452 to get close to 3,000? Grant, great thinking. We're going to multiply it by 4 first. 4 times 0 is 0. 4 times 5 is going to be 20. 4 times 4 is 16 plus 2 is 18. 1,800. Well, that's very low. We're going to have to go a little higher than that. So now we have 450 times, what should be our next one? Good idea, Josiah. I like that one as well. Times 6. 6 times 0 is 0. 6 times 5 is 30. 6 times 4 is 24 plus 3 is 27. That's pretty close. Can we go even one more? Would we be able to do 17 or a 7? No, because that would bring us over 3,000. So it's going to be 16. 6 times 450, 2,700. We subtract 0, 0, 3. Okay, so now we can't do any more. We have our number, and our answer is now going to be, we're just simplifying, D is greater than or equal to 16 and 300 over 450. Now, 300 over 450, we know we can, first of all, divide by 10, which would give us 30 over 45. Then we divide by 15. Really, once we get down to it, we would find out that D is greater than or equal to 16 and 2/3. So a lot of work over on the side there, but you always want to make sure that you're using that scratch paper. And as you can see, every single time our sign, our inequality sign, stayed the same. Now, let's go ahead and look at it if we have a negative. So this is again going to be one of our details and modeling. We're using the details we wrote down to answer these problems. Our question this time is going to be what, oh, I totally forgot to say what we were doing. We are dividing by a negative number. And our question is going to be, what are the solutions of negative 9y is less than or equal to 63. And then we want to graph the solution. Okay, so first of all, we're going to rewrite our problem, which is negative 9y is less than or equal to 63. And we're going to go ahead and get our variable alone. We are going to divide by negative 9. If we do that, they'll cancel out, and we're going to divide here by negative 9. Now, very important to remember, when you divide by a negative number, you flip the inequality. Remember, we're getting that from our property here. We flip that inequality sign. So let's go ahead and simplify. Our inequality sign is going to flip, meaning it's now going to be greater than or equal to. Negative 9 divided by negative 9 gives us 1, meaning that's canceled out. And all we have left is y is greater than or equal to 63 divided by negative 9. Well, 9 times 7. Oh, I had some trouble with that one. 9 times 7 gives us 63, meaning it's going to be negative 7. And that's going to be our solution. Now we can go ahead and graph that by putting our number line. Saying, let's make this negative 8, negative 7, negative 6, negative 5, blah, 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 blah. If we look at this, negative 7 can be a solution, so we put the dot, the filled in dot, and then we're saying y is greater than or equal to it, so we can go in that direction, greater than. So there we go, we flipped our sign, we did everything correctly. You just need to make sure you keep each of those things straight and correct in your mind. So that's why you want to have good, nice notes to help you out with that. Okay, our guided practice. Is going to be our PPSE numbers 7 through 29 odd. And then our independent practice is going to be our 3-3 quiz, which is assigned on your Pearson page. And that's everything for the lesson today. Good luck and go Buffs.